The first font?
What does that have to do with Bridget? I don't know.
Frank Knows. It's the name of the font. I don't really know why. Frank Knows. Knows, not Frank Knows. Frank Knows.
He knows that he's gonna murder someone.
I don't know what Frank knows, but he knows something.
We have 2 tests.
No. I have 2 tests that I have made up for this. One I give to a class that isn't doofuses, and one I give to a class that is doofuses.
Do we get number 2?
Don't know. Got to wait and see whether I got a class of doofuses or not. So far, I don't think so. So far, I think you're getting the real test, but we shall see.
Wait, so there's like a real test and the other test like really easy?
No.
Why is it 2?
All the tests are easy if you do your work. All right. Let's do a couple of things. Before we go on, I'm going to add something to our definition of variable. First thing, give me a definition of a variable. Again, if one of you says a letter or names a letter, I will be very, very angry. Do not give me an example of a variable. Give me a definition, a mathematical definition of the word variable. Excellent. An unknown, I'm going to run out of room, an unknown number. That is an absolutely spectacular mathematical definition. Now, how do we in math usually show a variable? Now you would say, yeah, we usually use shown with a letter. It's not always a letter. Sometimes it's a symbol, right? Like back in Mrs. Bad Crumble's class where she left a blank. Okay? Now, what? Okay. What does variable mean in English class, not math class? Ooh, trickery.
Trickery.
Huh? You guys don't know what the word variable means. When the weatherman says the conditions will be variable, you don't know what that means.
Oh, they vary. No? Okay.
Nothing like using the word to define the word.
No,
right?
like...
What does the word ephemeris mean? Well, it means it's full of ephemere.
They made up. No, like I'll...
Thank you. Okay. In English class, a variable is something that changes. Now, do those definitions work together?
Sure they do.
Of course they do. Because depending on what math you're doing to the letter X, you're going to get a different result. Yes? Yeah. What is going to happen to your result if the value of X changes? Then there'll be a different result. So variables can allow for change in math class too. Everybody cool?
We're chill.
All right. Now, the third thing that a variable is that you need to know in math class is this. Variables in math are, that's supposed to be an A, not ochre, are usually things we can count. So if you're doing a problem and there's things that change that you can count, we often, that's a good way to know that you're dealing with a variable. Everybody cool? All right. So, What do I have here? I have a pattern that has been made with sticks, right? Everybody cool? All right. So if a variable is something that changes and something that I can count, how many variables do I need to describe this pattern? No. No. I'll say it again. If variables are things that change and things that I can count, then how many variables would I need to describe this pattern?
1.
No. No. No.
35.
No. 2. Why 2, Perry? I don't know. I'm just saying numbers till you got it right.
1, 2, 3, 4.
All right. So now I've told you the right answer is 2. Now I'm going to wait until somebody can tell me why the right answer is 2. Bong, bong. Oh, your hand is up. What?
2 because it keeps adding like sticks.
What?
It keeps adding patterns of more sticks. It makes it look like it has 2 examples.
Excellent. So ours says I need 2 variables because we keep adding sticks. Unfortunately, ours has only explained why we need 1 variable. The number of sticks changes.
By 2 every time.
Yes. So that explains why we need 1 variable, because the number of sticks is changing. And we can count the number of sticks, as Paneet just proved, because we are adding 2 each time. So that makes, all right, it's something that changes, the number of sticks, and it's something that we can count, because the number of sticks is going up by 2 each time. So you guys have covered 1 variable. Lovely. What's the other variable? Nobody can see any other thing that is counted there. The figure number. Because as you can see, there is 1, 2, 3. Is it changing?
No.
Yes.
Can we count it?
Maybe.
So is it a variable?
Yeah.
Good. Luckily, there was a whole bunch of chickens in the world that just got their teeth pulled. None of you got that joke. If your parents were watching, they might have gotten that joke. I know your parents don't watch my YouTube videos. Relax. I'm saying if they did,
Oh, your YouTube.
they
I was like,
might
that
have
was my
gotten
parents
that
who
joke.
watched it. What's the joke?
Something that is very difficult to do. It is said that you are pulling hens'
They don't
teeth.
have teeth. Haha.
And it's so difficult because, of course, hens don't have teeth. So when a task is almost impossible, the figure of speech in English it's like pulling hens' teeth. Getting you guys to give me an answer is often like pulling hens' teeth. No, pulling a cow's udder is easy. You walk up behind it, not behind it, because if you walk behind it, they'll kick you. You walk up beside it, and you grab it, and you squeeze. But you don't squeeze like this. You have to squeeze finger, 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 finger. If, of course, you are milking a cow by hand, which very rarely do you. Usually you just attach the big old suction machines. Paneet, did you have your hand up there?
I forgot what I was going to say now.
That happens sometimes. You know what my mom says every time you say you forgot what you were going to say? She says, well, it must have been a lie. My daughter is only 9. She already hates that saying. So, of course, she made the horrible mistake of telling my wife, my son, and me that she hates it. So now, every time my daughter forgets, must be a lie! And then my daughter goes, and gets all huffy. It's super fun.
I just sit there and like.
I love messing with my daughter's head. Speaking of messing with people's heads, we just watched the first Now You See Me last night. That was pretty good. Everybody told me it was supposed to be pretty bad, but I enjoyed it.
Which one was that?
But that's because I like Jeffrey Eisenberg, or Jesse Eisenberg quite a bit. Even though I hated The Social Network. But I didn't hate The Social Network because it was a bad movie. I hated it because I think Mark Zuckerberg's an a-hole. But that's just beside the point. What? Yes, he made Facebook so he could get laid. Because he was too lame to talk to girls in real life.
How rich is he?
That's pathetic.
He's very rich.
He's rich.
Very rich.
He's a billionaire.
And now we're
I
gonna
feel too.
All right, so here we go. I want to do two things with this. Here's what's weird. Up until now, oh, I forgot to do this. There's two variables here. One is the number of sticks, which Paneet pointed out. Well done, Paneet. Two is the number of figures, which Bryn pointed out. Well done, Bryn. Up until now, how many variables have we had to deal with at any given time? I'll call your attention back to so long ago, yesterday, when you were dealing with variables. How many variables
Three.
have you had to deal with at any given time? One. You guys know how to deal with one variable. What is that variable? Depends on the letter. But you have only dealt with one, correct?
Correct.
Good. Up until now. Now we're going to start dealing with two. Excuse me. So, the first thing I have to do, according to my instructions here, is write an equation. Well, to do that, to write an equation, I gotta have what? What do I need to make an equation?
Numbers.
Some numbers. Excellent. So I need some numbers.
Math.
Yes, absolutely. I need some operations.
Oh, I'm good.
You're on fire today, Riley. What else?
Another one. Equal sign.
Yeah! And it has to equal something. Somebody stop him. Whew! He's like Jim Carrey in The Mask.
Is that it?
That's it for now. You take a break, buddy. That was a lot. Deep breath. Relax. You all good? You need a moment?
No, I'm good.
You good? You carry on? You gonna power
I
through?
can carry on now.
No. You're resting now. Okay. Yeah, it's tiring carrying the whole class, isn't it, Riley? It's a lot of work. It's 15 brains in here. You're the only one that it seems to be doing anything.
Well, come on, guys.
All right. So, Riley has missed one thing.
variable.
Yes. Look at that. It's like a tag team there. He's like, I get remembered. Aiden reaches out, tag, and he's over the top rope, and he's kicking ass. Nice.
Or it's a 1v1.
You also need a variable.
Hey, I got 3, you got 1, I'm still better.
That's what I'm saying. In this case, how many variables do we need?
One. Two.
1, 3, 2, 2, 4, 2, 2.
That's the whole point of everything we've just been discussing. All right. Now, next, we're going to give the variables names. Okay, we're going to assign the letters.
X, Y.
No.
PQ.
No. It's already been done. F is the figure number.
S.
N is the number of sticks.
How's that make sense?
Large amount.
Okay, everybody cool? All right, now, the next thing we got to talk about, and there's a whole bunch of white space here because there's a whole bunch of terms. For you guys, and this will apply for grade 10, 11, and 12, variables are either independent or dependent. Okay, I'm going to highlight independent in yellow. I'm going to highlight dependent in blue. They are one or the other. Okay? Now, before we go any further, and I'm not going to make you write anything down about this, we're going to actually speak of the words, what they mean in English. What does the word independent mean in English?
By itself.
By itself, okay. Alone. Yeah, we already have by itself. We have alone.
Goes by its own business.
That, now you're getting warmer.
Goes by its own what?
Goes by its own business. Because the first two definitions, while they're kind of true, aren't really right, are they? Am I independent?
Yes.
But am I alone? No, I've got a wife and 2 kids. So I'm not alone.
You got us.
No.
Okay? Not outside of school.
Oh.
Okay? What else? What was the other one somebody said? That alone.
By itself.
Well, by itself is alone.
Go about its
So, now we're in business. Usually it takes longer than that. Do you need some privacy, gentlemen? Because it would seem to me like you need some privacy. Okay, then.
I've been hearing weird noises from the whole class this morning.
Huh?
I've been hearing weird noises.
I know, it's weird back there.
Yep.
Yeah, there may be some seat changes.
Yeah, there should be some key changes.
All right.
He sat beside me.
So Bryn has informed us that independent means self-sufficient. Right? Nobody in the world is out there to help me anymore. Okay? I am independent. Everybody with me?
Sure.
What are you guys? Dependent upon what?
Our parents.
Your parents.
Your peers.
Even if your parents are bad parents, you're still dependent on them. They're giving you a roof over your head, clothes on your body, right? So we're all aware in English of the difference between independent and dependent, yeah?
Yeah.
Well, the definitions are similar in math. An independent variable, I abbreviate as IV because I'm too lazy to say independent variable a million times, okay? The independent variable, okay? The IV is what is the same for everyone all the time. It has a value no matter what. All right? The DV, the dependent variable, the DV has a value which can only exist or change when the IV changes. Okay? Everybody got that? So look at, we have 2 variables. One is the same for everyone, and one changes when the other one changes. Which of these 2 is my DV and which is my IV? Don't shout it out. Remember, there's only 2 choices. So eventually, if everybody starts shouting, somebody's going to get the right answer. You've got a 50-50 shot.
I got this.
I'm not going to reward you for that. I'm going to reward you for the reason that you have made that choice. So, when you all start yelling, which again gives you a 50-50 shot, so eventually you're going to get it, I'm not going to give you any kind of feedback till you have a reason for your decision. Okay? So everybody have a look at those two things. We've talked about what they mean. Which of those, F or N, is the independent variable?
F,
Why do you think that?
because it's the same all the time.
It is. It is exactly right. F is the independent variable. Why? Because if I cover this, oops, is there still a figure 1 under there? Yes. So it is the independent variable. Do you understand? It will continue to change, but you have no idea what the figure looks like. Got it? So our figure number is our independent variable. It is also known as the input. There's another word for you. I'm highlighting it in yellow because it goes with the independent variable. All right? It's the number that we can start from. Everybody got it? Yeah. All right. Which means, obviously, this is our DV. And you guys are smart kids. If the independent is our output, if the independent is our input, what's our DV?
Output. Well, great job, Craig.
Now, you guys may remember something like this back in like grade 6. Your textbook would have a picture that looked like this,
Oh, yeah. Oh.
and it would have a number here. And then it would draw this little arrow thing that looked like a pipe, and then here it would do some math, and then it would draw to another box, and it would do some more math, and then it would go to
Call it the math.
here, and this would be your output. And your textbook called it a function machine. That's why I said some of you. So this would be your input. You started with 7, then you added 7, then you took away 7, and what did you get?
Zero.
You got an output of 7. Right? Right? Did any of you, none of you saw that? None of your textbooks had the function machine in them? Really? That's too bad. I missed the function machine. Where was I? Right there. Okay. So we're all covered, right? Okay. Now, let's have a look at our situation. We haven't written this yet, have we? We haven't done our equation. We're just talked about equation or about variables. Okay. What is happening here? Puneet has already told us, and Bryn has just reminded us. What is happening to the number of sticks every time? We're adding 2, correct? Always, right?
Yes.
Plus 2, plus 2, plus 2, plus 2. What is it? Oh, there. What is the mathematical shortcut
Multiply.
to adding?
Divide. Multiply.
Multiplication.
Multiplication.
That's what's it.
No.
Yeah. Dividing. Because dividing makes things smaller. I've got one pizza. I'm going to divide it into pieces for all of us.
No.
Yes.
Multiplying is the shortcut to adding. So, if I continually add 2, what am I really doing? Multiplying by 2. Absolutely correct. Does everybody understand that? Right? 2 plus 2 is 4. 2 times 2 is 4. Right? 2 plus 2 plus 2 is 6. 2 times 3, 2, 2, 2, is 6. Picking up what I'm putting down? I know. So you can all quite plainly see that I am adding 2 right? Which is the long cut to multiplying by 2, correct? Now, if our f is the input and our n is the output, where does the math operation go? With the input or with the output? It goes with the input, because the math operation is changing our input in order to get our output. Does everybody see that? Okay? So, we know that our math in the equation that we are going to write, we haven't written it yet, our math in the equation affects the IV, or input. Yeah? Oh, my doctor is phoning me. Excuse me. Hello.
You have a
I'm well. How are you? I am working until 1:10. I can be there I was going to make it by 1:30. Yep. Yep. Still 1:30? Yep, no problem. That happens. Okay, no problem. Okay, bye-bye. All right, don't have to go to the doctor today. Got to go tomorrow. Nice. Okay, so the math in the equation affects the independent variable, right? So, let's look at this from a mathematical standpoint right now. Okay? Number of figure, it's the first one, right? So my input is 1. What is my output?
2. Output.
3.
Figure.
1,
2, 3.
2, 3. Yes?
Yep.
So my input is 1, my output is 3. Correct?
Yes.
Now, will my output ever be anything less than 3?
No.
No. Yes.
Not according to our chart,
On that chart, no way.
right? Well, yeah, we're only writing an equation for this pattern, aren't we, Paneet?
Yeah.
So my output, when I go to figure number 2, do I have that 3 still?
No, it's 5.
No.
Yeah.
Do I still have the original 3? I do. But how much has been added to it?
2, so 5.
Plus 2 to get a total output of 5, correct? Input, output, equation. Everybody with me? Okay. What's happening here?
You have a 3 and you have a 2.
I have a 3 still, right? Right? And I add 2 and another 2 to get 7. What happens here? Nine.
3 plus 2 plus 2 plus 2 plus 2.
Okay. We have already discussed that multiplying is the shortcut to adding, yes? We have already discussed that 2 plus 2 plus 2 is the same as 2 times 3, yes? Right? Right? We have already discussed that multiplication is commutative, which means it goes 2 times 3 is the same as 3 times 2, correct? Now back in grade 3, Mrs. Bad Crumble spent a lot of time stressing to you that 2 times 3 meant...
6.
No. It meant
You times, no, 3.
2 3 times,
Yeah.
right? 2 times 3 meant 2 times 2 plus 2 plus 2. 2 times 3, right? Okay, so here we're going to do the same thing. What has happened Now, we also know that the math affects the IV, yeah?
Yep.
So our IV has had 2 added to it there. 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2. So what is happening to our IV?
It's multiplying by 2 every
It's
time.
multiplying by 2 every time. So our IV is F, right? So the basic form for all of these is this. Our independent variable has math done to it, yes? Our independent variable and then some math gives me what?
Output.
Our dependent variable, which is our output. Got it? All right. So our independent variable is what here? F or N? F. What math do we know we're doing to F right now?
Multiplication.
Pardon?
Multiplication.
Multiplying it by how much, Panit?
2
2.
every time.
So there is our independent variable, and we've done some math, correct?
Yes.
And that's going to equal my output, which in this case is what?
11.
In this case, it is N. Yeah? Everybody cool? Okay. So now, once we've gone this far, we need to check, because we might be done. This is an equation, isn't it?
Yeah.
I have a letter, a variable, some math, and it equals something. So let's check if we're right. There's an F. Where can I put that F, that number, now? Because this is saying F equals 1. So where can I put that 1 now? Where there's an F, right? There's an F, cool? Okay. So what is 2 times 1? Equals what? 2. But it can't equal 2, can it? Because we can plainly see figure 1 had to have 3, didn't it? So 2 times F got me 2, but I need it to get me 3. So do I have enough math here?
No.
I got to add some more math. What will get me to 3?
Plus 1.
Plus 1. Cool? Now let's check again, because you got to check at least twice. You can't prove it. What's my next F?
2.
2. 2 times 2 plus 1 equals what?
No. 5.
5. Is our next output 5?
Yeah.
So do we have our equation?
Yes.
What is it? 2?
2 times 2 plus 1.
No.
2F
2F
plus 1
plus 1
equals N.
equals N. Does everybody see how to do it? Whatever we are doing to our output is the math that happens to our input. Cool? Now, look here. What do you notice about this?
Goes up by 1.
This is going up by 1 each time, correct? So what's repeating there? 1. So we're multiplying by 1, aren't we? Everybody with me? Which isn't going to change anything, is it? Now you guys are smart kids. If my changes to my output affect my input, then what do you think changes to my input affect?
Goes up by 1.
Output affects input. What would input affect?
The equation.
Listen to my words. This change resulted in repeated multiplication to the input, right? So these numbers, 2 plus 2 plus 2, gave us 2F, correct? So what will 1 plus 1 plus 1 give us?
3.
Repeated addition is multiplying. You were the one that said that. So 2 plus 2 plus 2 became 2 times f. What will 1 plus 1 plus 1 become? 1 times n. Right? These guys would go to here. Does everybody understand? We're going to do something with that in a minute. All right? But first, we're going to answer our question. Have we got our equation? Yes. What was part B? Part B said, I want the number of sticks in which figure? In figure 10. So what does F equal now? I need figure 10. What does F equal now?
22.
No. Don't give me the answer, Panit. What does F equal? Just F. F is 10. Where else do you see an F? In our equation, right? So our equation is 2F plus 1 gets me N. N is the number of sticks. What's F? 10. Plus 1, what's n? 21. 2 times f plus 1. Everybody good?
Yep.
Now I want to show you something. Because this is the easiest one, because these are going up by ones, right? I'm going to change this. Pretend you do not know 2 and 4. Are you with me?
Yep.
Okay. So if we don't know 2 and 4, then what do I have? I have 1, 3, 3, 7, and 5, 11, don't I? Everybody with me? If this is your pattern, you already know what the equation is, right? If this is your pattern, could you still do it? Let's check. What am I going up by?
2.
4. What am I going up by? 4. Soon as I get repeating, I know I have a pattern, right? Where does the output number go? Back with the input, right? So what is happening to F in this chart? It's going up by 4. 4 plus 4 plus 4 plus 4. So this must be 4F, correct? What's this one going up by? 2, 2. Where does the 2 go? To the output, to the N, right? Agreed? So 4F must equal 2N. Everybody still with me? Let's check. What's F there? 1. So what would go here? 1 F, right? So what's 4 times F? That would be 4 times 1, which would be 4. We cool? What does it need to equal? 2 N's. What's my first N? 3 times 2. 2 times 3, which is 6. What math do I have to put in here to make this true? Plus 2. So what math would I have to put in here to make this true? Plus 2. Now I want you guys to look at something. This was what we knew the equation to be, wasn't it? Right? But when I took away some of your information, we were still able to make this equation, weren't we? 4F plus 2 equaled 2N. Can you see a relationship between the two? What is it? You're on the right track. Are they the same equation? Yes. Why? They have the same You're so close. What would make this true? What number would go in that blank? Why? Because times by 3, and I get 6, right? Does this look different than 1/2? Yes. Is it the same value? Does this look different than this? Is it the same value? Yeah. We just divided by 2. Everybody with me? So, if they go up by 1s, it's real easy to get the equation. But if they don't go up by 1s, you can still do the same thing. You just follow the same rules. The only thing you have to remember is at the end of it all, you need your DV, your dependent variable, which is your output. You need your output to be isolated. So when I look at this question, is my output isolated? No, it isn't. How would I isolate that? Get rid of times 2. How do I get rid of stuff in math? Do the opposite of what you see. So I would divide that side by 2, and then I would have to divide everything by 2. Got it? All right. That's a lot of math crammed into your head in a very short period of time. It's worth a dab, Riley. Go ahead. I know, but you should maybe do another one, because it's worth it. Okay. Is everybody good?
I think I got this unit.
Okay, the bell is about to go, so instead of going on with the notes, I want to do one more here, okay? Don't even write it down, just think about it.
So the bell was 9:15?
Yeah, I think it was 9:15.
I thought it was 9:10. Oh, it's 9:15. We'll do one more anyway. In blue, what's happening?
Going down.
Minus 2, minus 2. We're lazy, so what are we really doing? No, we're multiplying by, no, multiplying by negative 2. So this negative 2 would have to go over here, yeah? Have these guys been given letters?
No.
Let's give them letters. P
R.
and R. So what is happening to P? Oh, then we check this side. What's it going? Up by 1. So we don't have to worry about P, do we? Because it's just 1s. We're cool, right? So what is happening here? What is happening to P? It is multiplying by negative 2, correct? And we know that it has to be the independent variable plus some math to get my dependent variable, right? You can, because the r's are what is changing. Remember, all equations are independent variable, p, plus some math to get to a result, right?
So your output's basically your equation.
Yes. So this is cool, yeah? We've done some math to our independent variable, haven't we? So we can make an equation now, equals r, right? We don't know if it's right. We may need to fine-tune it, correct? So let's fine-tune it. What's the first number I can put in for P? 1. And what does it have to equal for R? No. You see right there, R is 7.
5.
Negative 2 times 1 is? Negative 2 equals 7. Now, this is an unknown, isn't it? So it's just another variable, right? Right? How do I find the unknown? I got to get rid of this, don't I? Which is what? How do I get rid of negative 2? To where? Both sides, right? So if I add 2 to both sides, this blank becomes what? 7 plus 2 is 5? 9. So this blank becomes 9, doesn't it? Everybody with me? So this 2p plus 9. Now let's check if we're right. What's the next p? Looking sharp. What's the next p?
Chop it off.
2. Correct? What's negative 2 times 2? What's negative 4 plus 9? Positive 5. Is it? So we've got it right. That's the new equation. Does everybody get it?
Yep.
These are the math that gets done to the input. These plus 1 plus 1 plus 1 are the math that gets done to the output. Everybody cool? All right. We still got 9 minutes. Let's see if you really get it. What's happening? What's happening to both sides?
Multiplication and addition.
Plus 1, plus 1, plus 1. So what's repeating? 1, 1, 1. So we are multiplying by 1, yeah?
Yes.
So my h's are times 1. Does that mean h will change?
No.
No. What's happening here?
4.
4, 4, 4. So that means my s's are what? Times 4. Right? Describe the number of hits in terms of the number of swings. Right? The number of hits is...
Are you talking about a fight or something?
Are you used up?
Can we do it yet?
No.
No. We got to do this math, don't we? So we know it is 4s has to equal what? H. Right? That's the basic equation here, isn't it? 4s equals 1h, yeah? So that's the first part. The number of hits is 4 times the number of swings, yeah? Okay. Now let's check. What's the first s I could have? So it's 4s plus an unknown, right? So it's got a blank. 4s, what's my first s? So what goes in for s? So it's 4 times 1, which is what? 4 plus a blank equals what? H is 5. How do I find what that blank is? I need to get the blank by itself. So what do I do to this positive 4? Minus 4, minus 4. So the blank equals what? 1. So what goes right here? In our blank? 1. So what goes right here? 1. So what's my new equation? 4s plus 1. Now, when s is 10, what's h? H equals 4s plus 1. What's s now? 4 times 10 plus 1. What is it? 41. Does everyone see how it works? Now again, these are incredibly elementary examples, but the math holds true even when it gets more difficult. Got me?
God.
All right. Now let's talk about an actual real-life situation, not numbers of sticks. Tegan goes to the carnival. That's how much it costs to go. Right?
That's expensive.
Everybody with me? All right. So, what does this mean? Does everyone have to pay it?
Yeah.
Yes.
If I go on rides, does that $5 ever change? No. I have to pay the $5, yes? So $5 is what? Constant or variable? Constant. Every ride I go on changes the cost, doesn't it? So the rides must be what? Variable. Everybody cool? Right? And what is the thing that will change depending on my rides? How much it costs me to go, right? So rides are variable, and then we know we need two variables. What's the other variable? Variable is rides, and what else is a variable? The cost. Right? Because that's what we're counting here. So I got two variables. Agreed? How much does the cost go up every time?
$2.
$2. Is that a pattern?
Yes.
Okay. Because, BC, because the output, my output is my cost, yes? Because my output, which in this case is cost, changes in a predictable and repeated pattern, we have a linear relation. And please highlight linear relation. All that means is it's going to do this. 444, 111. Okay? What if it was 777, 222? Would that be in a linear relation? A linear relation is when the output changes predictably. So, 444, every time it's 111, right? So that's a linear relation. What if it was 777, 222? Is that repeating? So is it a linear relation? Yes. What if it was 754, 123? No, because that's not repeating. Got it? All right. So I've got my constant, I've got my variables. So now I'm saying I got to write an equation. What did we need here to make an equation? I needed this chart, didn't I? What did your previous teachers call that kind of chart? You need some teachers call it,
Graph.
no, it's not a graph. Some people call it a T-chart because it looks like the letter T, right? Some people call it a table of values. That's what math guys are going to call it for the rest of your days. Okay? So, let's make one. What goes on this side? Look up. What went on the left here? Input or output? Input. What went on the left here? Input. So what goes on the left in a table of values? Input. Or your independent variable, yes? What is my independent variable? What is the thing that is the same for all of us? But remember, it's something that has to change. We'll come back to that. Think about it.
Mr. Meyer, should I get Mark Booker tomorrow?
Yes, I already said that.
Already?
Good luck. I hope everything's okay.
Yeah. I'll be back. It's like my 8th time getting a concussion, so the doctor might make me get like a sports restriction or something. Period.
Although like I'll fix, you know, the streaks and then these streaks, but
Oh, I don't want to know what's happening.
no. Yeah, it did for us, but like sometimes it doesn't work.
Are you hilarious?
How does it happen?
It says coming out at really, it's coming from that jelly bean.
Oh my god.
26, yeah.
How many do you just say streaks and you actually talk to them? Only have one.
Business.
Yeah, I haven't seen Finding Dory.
So, you need a table of values, right? Our independent variable is the thing that doesn't change for everyone. Okay? We know our variables are costs and rides, yes? What is the thing that's the same for both of us? How much, for me and all you guys going to this fair, what is going to be the same? How much we pay to go in, or how much it costs to go on each ride?
It costs to go into it.
No, how much it costs to get in, that's going to be the same. That's not a variable. It never changes. The variables are how much our total cost is
Will only be the same.
and how much each ride is, yes?
Yeah.
If you go on a ride and I go on a ride,
Uh-huh.
do we pay the same?
Yeah.
How much?
You might just
$2, right?
Yeah, well,
Wait, never mind.
If we go on, so the cost of the ride is the same for both of us, yeah? So that must be my independent variable. Do you see why?
yeah.
Paneet rides a ride, Riley rides a ride, Perry rides a ride, they all pay $2. So even though the cost of each ride is variable because it's changing, that $2 has to be the independent variable, right?
Yes, that is true.
Then our dependent variable must be our cost, right?
Yeah.
So, what is the fewest amount of rides I can go on at a fair? No. 0. I walk into the fair, I look at all the rides, I don't want to ride any of them.
That's the
So what is my independent variable? 0. I could ride no rides. Have I still paid to get in there? How much? $5. Aiden goes in there and he sees the zipper. That's his favorite ride. He rides it once.
I've never been allowed.
How much did he pay to get in?
You're too short.
But he paid more than 5, didn't he?
Yeah. 7.
Plus 2 to get 7, correct? So this is my first output. This is my second output. Everybody cool? Paneet goes to the fair. He sees the zipper and the gravitron.
Sounds like a...
Some of you will know it as the Starship 3000.
Was that that
Yes.
freaking...
Is that Star Wars?
No.
It's a ride.
No, I.
Did Paneet pay $5?
Yeah.
Yes, of course he did, because he walked in the door. Then he paid the $2 per ride how many times?
2 times.
Twice. To get what? 9. There is my third output. Now once I have 3 outputs, I can see if there's going to be a pattern, can't I? What are my outputs increasing by? 2 plus 2. Where does this 2 plus 2 becomes times 2, doesn't it? Right? And where does that times 2 go? With the R or with the cost? With the R. Why? Because all equations are independent variable, then some math, to get my dependent variable. Okay? So what was my independent variable? R. What math was happening to R?
Addition.
Times 2, because we're doing it more than once, so it becomes times, right? Now, we don't write R times 2 in high school, do we?
No.
What do we write?
R.
No,
R squared.
2R. No, R squared would be R times R, not R times 2. 2R, right? Now, is that my independent variable with some math?
Yes.
Yes. And that will have to equal my dependent variable, which in this case is C for cost. Everybody cool? So now I check. There's a possibility here that there is going to be a blank, right? Right? So there's plus a blank to get this. Cool? Is everybody okay with me here? So now we check to find the blank. Do we know the first R? What is it? 0. So it's 2 times 0 plus a blank gets me what? C, which is the first one is what? 5. 2 times 0 is 0 plus blank gets me 5. Solve for the blank. Minus 0 minus 0. What's the blank? 5. What? So if this is the blank, it's going to go here, isn't it? Which gets me 2R plus 5 gets me the cost. Now you guys should notice something here. 5 plus 2, 2. R was 2. 5 was constant all the way down. What's the constant in our equation? 5. Everybody see? So the next question was 4 rides. So this is A. We're done. Now let's do B. How much does it cost to go on 4 rides? Well, we know that cost is 2R plus 5 will get me cost. I want to know 4 rides. So what do I do? 2 times 4 plus 5 equals cost. What's 2 times 4?
13.
What's 2 times 4? Plus 5?
13.
13 equals cost. So how much will Tegan need if he wants to go to the fair and ride 4 rides? $13. I go to the fair with the girl. Ooh. I don't want to look like a wuss. So I go on 20 rides. How much does it cost?
45.
45.
Great job, Harry. I thought.
Except I'm taking a girl.
9 times 2.
Because only a chump wouldn't pay for a girl if he asked her to go to the fair.
Craig doesn't go on dates.
I came up with that.
Where does Craig go?
Daddy
With
says
this
yes.
my joke.
Is everybody good?
He goes with this.
Is everybody good?
Nothing wrong about going with
Okay. Now let's take a moment and discuss independent and dependent variables, because this is something that people have a lot of trouble with. Okay? Is everybody ready? I get paid $15 an hour. Just pretend. What are the 2 things that are variable on my paycheck? Remember, variables are things that changes. I get paid $15 an hour. What are the things that change? 15 doesn't change. I get paid $15 an hour. The amount of hours worked is one variable. And what is the other thing that changes on my paycheck?
The total you get.
The total I get paid, which is dependent, which is independent. One of them, either hours worked or total pay, has to be independent. The other one has to be dependent. Which is which?
Mr. Mars, what's your opinion on Donald
The
Trump?
hours are dependent.
The hours are,
Mr. Myers.
you can't just say both, Dylan. Look at the definition of independent variable.
Hours are independent.
The hours are independent. Why?
Because they're changing.
No. Because they're the same for everybody. You're getting paid $15 an hour. The person sitting on the curb beside your shop is being paid how much per hour?
10.
0.
None.
Oh.
Is the hour passing for both of you?
Yes.
Is an hour the same for both of you?
Yes. No.
Yes, it is.
No, but you just don't get paid as much.
Doesn't matter. The hour is still
an
passing.
hour.
So the hours are the independent variable. Your pay depends on how many hours you work. If you don't work, you don't get paid. But the hours are still passing. Do you understand?
I do.
Biggest hint I can give you in a math class. Time is almost always your independent variable. Because time is passing for everyone, no matter what. Okay? Almost always. Time is your independent variable. Everybody cool?
Yeah.
Great. Let's see if you really understand it. Go. My man Marcel's working in a book packaging plant. He gets paid $50 a day. $50 a day! Plus $2 for every box he packs. Write an equation for Marcel's pay. Can I write an equation without a table of values?
No, you cannot.
No. I need a table of values. To do a table of values, I need an IV and a DV. What goes on the left?
I
So we got to figure out what's the IV, what's the DV. Now I just gave you a big hint. What's the IV?
50 bucks a day.
No, because $50 a day doesn't change. It's not variable.
$2.
The boxes are independent, aren't they? Because Marcel's packing boxes, Aiden's packing boxes, Riley's packing boxes, but their pay depends on how many boxes they pack. So IV is boxes. And we have said B is the number of boxes. So what goes here? On the left, little b.
Little B.
Our dependent variable is our pay, yes? And our question tells us our pay is big P. Where does it go? On the other side. Right? If I am a lazy sack of poo
That would be Riley.
and I pack no boxes that day,
That's me. Yeah.
so I pack 0 boxes, how much am I getting paid?
0 P.
Wrong. $50.
Oh, lit. I can sit around and get 50 bucks.
No. Because you will last one day and then they will fire
Oh,
you.
they'd be like, oh, where'd all the boxes go? I'd be like, oh, I already shipped them out.
If you pack 1 box, are you paid $50?
No.
No, $2.
You're paid 50
$2.
plus 2. If you pack 2 boxes, you are paid 50 plus 2 times what?
$4.
2 times 2 because you packed 2 boxes. If you pack 3 boxes, you are paid 50 plus
2
times
3.
3. What if I pack B boxes? I'm paid 50 plus,
You say 50.
I am paid 50 plus,
She said it.
Plus the number of
What's
boxes.
B? Like, I don't get what.
2
Pop.
B. There's your equation. Pay equals 50 plus 2b. 50 plus 2b. 50 plus 2. How many boxes did Marcel pack?
2.
20. Says right in the question. 50 plus 2 times 20 is 40. Marcel got paid $90 that day. Does everyone see how it works? Say my name, say my name. Does it work?
Yes.
Does everybody see it? Now, I have given you a couple of different ways to write an equation. Very subtly, I showed you 2 different ways to figure out your equations, didn't I?
Yep, you did.
You can do it this way, or you can use algebra and do it this way. Do I care which way you use?
No.
Not even a little bit.
That's so creepy.
As long as you do something. Oakley dokley,
Artichokely.
oakley dokley artichokely.
Let us move on. Guys.
Let us move on. Cabbages.
Come on.
That was for an hour.
But first,
That was.
we go to the outline and we talk about what you're actually going to work on for a little while. You are going to work on page 158.
I don't know what you're like.
Okay, sometimes it runs off.
And you are going to do numbers 4 to 9. You are going to do number 11.
$158.
Okay, Mr. Myers, now may I ask you a question?
You are going to do fitting.
Our number. 4.
And you are going to do
I can't finish that much. I'm a very slow worker.
I'm walking.
17 and 20.
Looking at me.
And you are going to work
Can you stop talking like a German?
9. And you are going to work
Sorry.
for a while.
You?
You may study, of course you can.
Can I go to the washroom?
No, you can